Okay, so let's solve this exponential equation. Okay, we have 8 to the x power equals 16. Okay, so an exponential equation is an equation where x is in the exponent, and those are usually harder to solve than a polynomial equation because, well, let's see, it's hard because you can't do things like factoring or like regular algebraic techniques, manipulations like subtracting for both sides, dividing both sides by the same number, things like that doesn't work because you have this exponent here. It's not a multiplied number or it's not added to a number. Okay, so what you want to do is get this x to be like a regular number, like something times 8 or something like that. So the trick is when you have, when you take a logarithm of something, the exponent will become the coefficient. That's one of the log laws. Here's the log law. Okay, it says the log of a to the c power. This could be for any base, so base b. It's always equal to c times the log of a, and the base is b. Okay, so this exponent here is going to become the coefficient as long as we take a log of it. Okay, so this is one way to do it. So one way to do it is take the log of both sides. Okay, we'll take the log of 16 as well. All right, now the x is going to come down here. Now, before we do that, you could take the log of any base. This could be any base here, but we'll see in a moment which base might be the best log to do. Okay, so we're going to get equals 8 times log of 8 equals log of 16. Okay, so the answer, now all we have to do is divide both sides by this log of 8 and we'll get x. So x is going to equal over log of 8. Good. And this is the answer. But if we want to simplify this a little more, what would be a good log that we should have picked so we could actually simplify? So when you have a base here, okay, let's say the base is, let's say we pick 10 as the base. So the log of 16 with base 10 would mean this 10 to what power is the answer is going to equal 16. Now 10 to a power, there's no easy number that equals 16. So 10 is not a good base to pick. A better base to pick is 2, maybe. 2 is a number that 2 to a power to 4th power gives you 16. And 2 to a 3rd power equals 8. So let's pick base 2. You could pick any base as long as you're taking the log of the same base to both sides, then that's fine. Pick base 2. So the log of 16 base 2 is 4, and this would be 3. And the answer is 4/3. Now this would have worked with any bases. If you pick base 10 and base 10, if you put this on your calculator, you would also get 4/3. It would always work. Now there's another way to do the problem. Okay, let's take the original problem. 8 to the x equals 16. Now another way, if the bases are the same, okay, so when you have a problem, okay, let's say you have b to the x power equals b to the y power. If you have an exponential equation, the bases are the same on both sides of the equation. The variables, you don't know what they are, but we know they must be the same. This is one of the properties okay, so x and y must be the same. So if we could turn this problem into an equation where the bases are the same, like here maybe is 1, then we could actually get rid of those bases and just call these exponents, set an equation. So here, we actually could just say x equals y. We could get an equation, say something. So let's do that. Okay, what we could do is 16 is 2 to the 4th power. 8 is 2 to the 3rd power. So good, we have some common base between them. But this is 8 to the x power. So we're going to say this is 2 to the 3rd raised to the x is equal to 2 to the 4th. Okay, to continue this over here. Good. Now, we want, this has 2 in the base. We can make this have 2 in the base as long as we, now there's a property of exponents. When you have something raised to a power, you can multiply those exponents together. So we could actually say 2 to the 3x power equals 2 to the 4th power. Okay, and that's true. And now we have 2 is the same base. We could actually say 3x must equal 4. Okay, so therefore 3x must be equal to 4. And therefore x is going to equal 4/3. Wow. Isn't that amazing? We got the same answer and we did it 2 different ways. Okay, so just to review for a second. The first way, we took the same log on both sides in order so the exponent will become a coefficient. We divided both sides by log 8. Okay, and we got this over that, and that is equal to 4/3. The second way, we tried to get the bases the same, 2 and 2. Okay, but this is going to be 2 to the 3rd, 2 to the 4th, raised to the x. And now we'll multiply these together so we could just have 2 as the base. So 2 to the 3x equals 2 to the 4, and then we could equate the two exponents and solve for x. All right, thanks.